Hello. Today we are talking about creating annoying geometry and my flaws with it. So something I've been kind of struggling with um, recently has been in all my tests. The film travels up through here, goes over this little guy here, and up through this roller here, but it seemed to catch on this geometry here a little bit. So I got to figure out how. So I added this little arc here, and that was helpful, but I don't know if that's actually going to solve it. And because this part has to be machined, this arc is not necessarily doable either. Like I'd have to do a little bit of this, just like about 0.5 or something, and then some poor machinist somewhere would have to. Well, maybe someone somewhere would have to get a bit in there and figure that out. But there's also a world where if you look at old Aton references, they have a roller not on this side, but on this side. And I didn't see any scraping from this, like the actual path that it takes. It goes over, under, and like through here. There was no like film scraping in my prototype version, so I think this side is actually okay. So I might add a roller over here somehow. But Austin just finished this lovely PCB here, which has some Hall effect sensors in it. And as this plate rotates, it moves the magnets around the center pivot, and it allows us to calculate its position and timing, which will tell us how much is left on the reel, and then that will be shown on this little paper display here, which is like a bendy paper display. Um, but yeah, currently this is kind of where we're sitting with the magazine. Oh, I also changed out these rollers here to be belts instead of smooth belts. Um, I was having an issue earlier with smooth belts where there wasn't enough friction on this end, and I either need to add another roller like right here, or I just said like fuck it and use actual belts. So these are 3mm standard belts, which are these two, and I'll probably just 3D print up a test of those in the near future. So um, yeah, I mean this is kind of where we're at right now. Um, and it's really coming along. Let's see here. That's the other side lid, and then that's the side cover. So currently, as it stands, the movement and pull down hook and everything is more or less locked in place. There is a little bit of contention, excuse me, with trying to figure out this cover inside of here. So there's a piece of glass that sits on top of this, and that glass. Actually, this is good to know. You never get everything. There's a piece of glass that sits on top of this, and it covers this screen here. And the screen projects your time code and data and everything um, as you're going. So, like, if you hit record, for example, it'll have 6 frames before it, and it will flash that. It will flash whatever the time code is onto those 6 blank frames, and then it will start moving the film through. Um, and that I mean, I can't figure out any other way of doing it. I was trying to maybe get a screen inside of the magazine, but we kind of, I don't want to risk any light leak inside of the mag for obvious reasons. Which is actually a really cool thing about the mag too, which is we have these, one moment here. There's way too many. I gotta clean up my folders, so sorry about that. This right here, this little U12 chip that Austin put in, this is actually a light sensor. So we'll be able to tell if there's any light leak inside the magazine and warn you if your reel has been uh, defected, you know, if something bad has happened to it. There's one on both sides actually, so there's one on this side, and then there's also one on this side which shines through. It doesn't shine, there's no light, it just receives info through here. So it's a very sensitive little light meter in there. And it's actually a pretty fancy light meter too. We're using it on the Lexicon version 2s. So today the big thing was tackling the belt drive inside the mag, and then figuring out perhaps maybe a more elegant solution for the bottom block. Because right now, as it stands, I think this might have enough lip, so you can just like remove the magazine. Okay, so I'll break it down. So, because this will help me too, just keep track of everything. So in the top plate here, this is our, see, keep finding things, and, delete, what? Hold on. Sorry, just like leaving. All right, is Fusion gonna crash? Does that? No? Okay, cool. And then actually, yeah. No, it's not gonna let me do it. That's fine. I'll come back to it later. Yeah, maybe it will let me do it now. Let's see. Yeah, that's good. Okay. Nice. I always worry about light leak in these places and areas up here, but there's like a decent amount of overlap, so I think that'll be okay. I'll have to, I do a lot of checking like later on, and as like this gets inserted, there's like little covers and things that kind of help with all that. So there's a cover on top of this, and then there's the inner cover from the magazine. But anyway, so what I was getting to was the top plate, which if we get rid of the body here, you can see it slides into this dovetail here. And then on the other side of this dovetail, there are these two magnetic pogo pins, which is where all the power and everything comes through. So basically you have a pogo pin set up top here on the mag side, and then all the power is routed through this little tiny top channel down through here, and there's a channel that I dug out, and we'll have to get some kind of mounting tape or something to go and guide it, but it will come down through this channel here and go all the way through this guy, all the way up into the PCB, into the screen and everything. Yeah, that's the current plan. So there's this guy up here, which if we get rid of this, so you can see, there is a little spring-loaded key here that is connected to the top piece, and when you pull it back, it releases the mag. That itself is not necessarily enough. I wanted to have 2 points of connection, so there's also this bottom latch here, which is on a nice, pretty heavy spring. The only downside to this is that, let's say you unlatch this from the top here. Now, this guy is connected at the bottom still, so how do you get this bottom one undone? And so I was thinking, okay, maybe this ledge will be small enough where you can kind of bend it out or something. There's no real way to test that though until you have every piece in hand. And then I was also thinking maybe I'll build some kind of servo in with a button up top here, and then the button will tell, oh, I pushed this back, so move the servo and disconnect this latch down here. But that got really complicated, so I don't think I'm actually going to do that. I think what I'm going to end up doing is probably something a little more mechanical, and I haven't quite figured it out yet, but it's coming along. So I'll probably end up working on that tonight. Is the goal. There is I'm missing this. So what I would really like to be working on right now is the screen module, but we actually just changed to a different screen, so I have no reference PCB for that, so I can't really work on that right now. And I mean, the sensor is pretty much locked in. I was going to use a Peltier unit for cooling the sensor, but after some tests, I think that the 10% cooling efficiency that it gives you is not worth it. So I'm probably just going to stick like a little 40 millimeter knock to a fan in here and have it blow up through some vents that I'll carve in the side here. Um, and then there's obviously a little bit more light leak stuff I have to do around this corner here. I want to add a little warning and like a little laser engraved thing here that says like don't no touchy on this inner bit here. And then that's all stuff that I can do later. It's like the details, which I gotta remember to not get super bogged down. Oh, and then the last little piece too that I have to worry about, maybe not tonight but later, is that I have to measure the stick out from the CFast reader, because in the first version it stuck out about I don't know, 15 or so millimeters from the actual card reader, and I would like it to be more flush inside of the body here, so that's kind of a nice priority. And then we also have to add the door for it, which a lot of people's feedback was add the door for Cine Gear, so I'll do that. This is like the screen we're potentially going to use, and it's 900 nits, so it's way brighter than the first one. Um, and that will be a lot better for people to use in the daylight, which was something I was noticing at Cine Gear. Let's see, so and then of course, so cage parts. So my buddy Jared from Possum Innovations, Possum Industries, I sent him the file. He's like, "Wow, that's really cool, but what's the hole pattern?" And I was like, "Oh, it's just some fucking random holes." And he's like, "Okay, well that's terrible. That's not the final version, right?" And I was like, no." So no, it's not. I'll fix that. Don't worry about it. But cool. So right now the main priority is kind of figuring out this latch. So I have to name these bodies real quick. So this will be back cam swoop. And pardon my spelling, it will get fixed later. Latch. Latch, and then oh yeah, you're new, you're the top mag. I guess we'll call it I'm blanking. Top mag. Sure. And who are you? Oh yeah, you're the fake left side. Or right side. Cool. So all these components. Good. Cool. So I think I'm gonna first clean up these inner edges here before I do anything else. Which means, yeah, let me mute the mag real quick. Yeah, I'm gonna clean up these inner edges here so that we don't have to deal. Come on. It's not gonna let me. Any light leak. And again, I always what's the number one rule? Always apologize to your machinist. But abuse them politely. That simply will not do. Actually, yeah, no, yep. So Fusion does that glitch sometimes, where if you select the face that you're trying to do, it will hate you. Let's see, can I make it this time? Yeah, let's do that, and then let's just go straight ahead here. And then bring this out. Yeah, that'll work. Yeah. Nope. Come on. It won't let me. Yeah, that won't. Not really what I wanted, but actually that does. That's smarter. I should have done that from the first get-go here. Yeah. Interesting. Very interesting. What is this? What's this? Okay, weird. Right. I don't fully understand everything Fusion does, and that's okay. Yeah, let's do. I remember Fusion did this thing where it like defaulted your it defaulted so when you clicked through objects' faces, it wouldn't do it anymore. Like it wouldn't like actually like if I wanted to, I should be able to select the other side of this face when I was doing like pushes and pulls or whatever. And then there was a while where Fusion like disabled that, and I was devastated. I was like, "The fuck am I gonna do anymore?" But it was just a blanked out thing that I totally missed. So this is not acceptable. How am I gonna fix this guy? Actually, let's do this. Let's get it kind of uniform in here. Yeah. Again, we always apologize to our machinists. It's just polite. You just want to be polite. So let's make sure so that's interfering with that. So I think I'm actually gonna take a chunk out of that piece. And mute you and provide a little Clarence here. Little Clarence Thomas with his little bus. Okay. Is this radius? 0.5. Yep. Come on, thank you. And then nope. Let's see if it will let me do it. No. Oh yeah, I need to not scale it. 0.5. And then I click here, and I click trigger chain. I click here. Sure, that's not gonna work, but yeah, it's not gonna work. Okie dokie. What do I want to do about this? Well, I guess I could keep it. This is awfully close. That minus 0.5. Yeah. It did the whole thing. That's fine. That's great. That's what we wanted for sure, Fusion. No. Yeah, that's what I want. Yeah, that's pretty reasonable. The thing that I'm kind of learning the more and more I do this is that despite what I put on mechanical drawings, tolerances are more of a suggestion than a feature. And I don't think people really respect them, and that's okay, because I don't either. I would again I as a machinist myself, or as you know, I don't know. I mean I'm machine metal, but as a machinist, I also hate engineers and designers. So I know what that's like, and I apologize. Let's see if it's gonna fuck me. Okay. Oh, okay. It's just not interested. Finagle it a little. Oh, make it interested. Something like that. That's nice. Really? You don't like that? That real quick. We'll do a little follow up with you, even though we really don't need to. Ah, I did again. Okay. Interesting. Really doesn't want to follow this path, huh? Wonder why. Probably because of that. Sure. Really? Really? So take you. There we go. Ah, okay, okay. Didn't like that. How far can I get? There we go. I can get up to here. That's pretty good. Interesting. Hmm. So something to keep in mind too for all this is that uh, generally this entire structure as it sits is not really machinable. Like you could, if you have it on the 5th axis and you bring it around this path and up through here, potentially you could do it, but as soon as it hits this, it's over. There's no machining that. So I need to be smarter about this. I'm just kind of diddling shapes right now, which is, I'm tired. It's late. It's not late. It's only 10. So well, let me do this for real. Whoa, hello. Yeah, okay. Sorry about that. And then honestly, I don't think anybody would complain if I just filled in this whole thing. Yeah, that's exactly what I meant when I said do that fusion. Good job. Frustrating. Sure. Let's see if it will. Let me just delete this and make it straight. No, it just does that. Okay, that's cool. So I mean, if anybody is using Fusion right now, I would highly recommend you don't, because it is the worst program ever made. But that's the truth for every CAD program. Just so you know, every CAD program you ever will use and do use is the worst program you've ever used and will use. And there's no getting around it. I use SolidWorks for I don't know how many years, 3 years now, and I honestly prefer Fusion at this point. But it is just a matter of preference, so I wouldn't worry about it. Yeah, it's closer to what I wanted. And then let's build up this guy again. And then the goal is to have this 5th. Actually, this is the 11th version of the camera, but this will be the 7th prototype. The 7th prototype needs to be in by late July. So there's a lot of PCB work that has to be done right now, unfortunately, that I don't have control over. I'm kind of at the whim of Austin, who is my business partner. But the movement stuff and the mag stuff should get sorted out by next weekend. And by movement, I mean the movement works great, and I will probably post a video at some point soon showing the movement off because it's so cool. I love showing it off. But it works great at anything under about 100 FPS. If you go beyond 100 FPS right now, it starts making this noise that's a little scary. It's not 7, huh? What are you? 7.111. Cool. So 100 frames a second is kind of what we're looking like. Although that's what we said we would hit. I mean, I'd like to hit higher, but I don't know. I mean, we'll probably just limit it to 90 if I'm being honest. Which I think most people will be okay with. 90 frames a second on a film camera is awesome. And then there's also the matter of our digital camera, which the digital camera actually, I have to make this flush with you. Oh, you're lower. That's right. Okay. Should I cancel it out? No, here. Should have kept that deleted. The digital camera right now, we can do up to 120 frames a second at 720p with when we upscale though there's like so when you basically the idea right is that we feed all of the camera stuff, the camera's info, which is over a 4-lane CSI. We feed all the sensor info into NVIDIA Jetson board, which Austin has designed, and that board, that's too close. Is it? We'll see. And that board has all the shit on it that we need. But the main problem is encoding H.264, which isn't necessarily a problem. It's just it's doing it live. So what I think everybody really wants is they want to be able to record not H.264, I'm sorry, ProRes 4444, so quad HD or quad 4 ProRes, and ideally we would just be able to take this is thick, isn't it? Yeah, okay. Ideally, we would just be able to take the image straight from the image sensor, write it to a FPGA chip, which is like a really fast. It's basically like an analog version of a digital chip, if that makes sense. So it's like you have like an FPGA chip, and it does one task really fucking fast, right? Like so a lot of cameras use FPGAs to encode or decode whatever their footage is or whatever the image sensor is, like everything, like image pipeline wise, like all that can be based on FPGA. So they're really cool, but the main problem with FPGAs is that they've traditionally been very difficult to program. And so Austin has figured out a way to do it using artificial intelligence. And it's gonna delete that. I know. Oh, okay. And it works really well. So there's a lot of like tools and things now that exist. Jesus, really? Really? There's a lot of tools now that exist in the world of artificial intelligence, like large language models that can program FPGAs, and they can do it really well. So that's been something that we've been playing around a lot with. But we still need an NVIDIA Jetson board to seriously. Hold on. We still need an NVIDIA Jetson board so that we can. You're not even gonna let me click it. The fuck, dude, Fusion. Okay, that one. that one. Okay, so it's just ignoring what I want to do. Sure, just do that. Sure. Cool. Thank you. So yeah, anyway, so FPGAs, basically the biggest problem that we've been having before and now is that our NVIDIA or our main compute unit, it has to, it's the processor, right? And it has to run the camera. I'm not mad at this, but I can't have it, unfortunately. Here, let's mute this real quick. Yeah, and then let's go over here. Yeah. So we'll delete that, and then I guess I'll just close this out. Just want to close this up. Let's see if this will do it. Sure did. That won't fix it. Yeah. Will this fix it? Kinda. What's this curve? 31.781. Yeah, anyway, sorry, I keep getting distracted. So FPGAs in this case are not that useful for us because what we want to do is we want to push our trained image pipeline through the Jetson and then have that create a LUT for us that will, it's like a live LUT, so it will change as the, the highlights and shadows are registered on the sensor. So it'll be like, oh, this is a film stock from Kodak that's like a 16 or like a let's say 200 or whatever, or 400 film stock of some kind, and it will change what the image should look like based on that from the Jetson instead of the whatever the FPGA would normally be, which is why like LUTs and stuff are more common than what we're doing. Because typically you would literally just like say, oh, I want this to look like ProRes or whatever. I want this to look like, whatever custom LUT you have loaded, and then the FPGA would just translate that and be like, okay, cool. Like here's the lookup table. It's applied to the image, and you get that out as like a proxy file or whatever. But in this case, we want it to learn its surroundings and be a little smarter than that. So the it was a 2.5. It was a clean 2.5. Got the sticky fingers. What the fuck are you doing? What is this? Hold on. What the fuck is that? Is there something here? No? Hold on. What the fuck is that? What are you doing? Stupid ass fusion. Really? Okay. All right. Huh. All right. I have to do this. Let's just say fuck it, whatever that is, right? It's not going to be enough clearance for this. That is fine. So that's not quite what we want to do. And the problem that we've been running into is that so we used to use a little chip called the Rock board, which is like it's like a Chinese version of a Raspberry Pi, and we wrote the drivers and everything for it. And it worked out really well, but oh, that might be enough. What? Why did you pick that one? Okay. But the Rock board, it was not strong enough, is what I'm getting at here. It's the long and short of it. So basically what it does is it records the raw to bare image right to the right from the sensor in raw, or whatever you're like DNG or something, and then it as it's doing that, ideally it would be doing that, and then at the same time it would have an FPGA that's dedicated to ProRes or to, you know, like I don't know, H.264 or 5. And then as it's writing to, as it's taking the broad bare image, it's translating that through whatever the FPGA is, and then translating that image to whatever codec you want. And that's kind of what we want. But at the same time, you know, because then it takes a lot of load off the CPU, and then you're good to go. You can just, you know, do your thing and you're done. But I have to round this out and this. Oh, sure. That's gonna make somebody mad, but sorry. Um, so yeah, basically you would do that. You would take your chip and you would output it to whatever codec you want, and that would have its own either dedicated FPGA or something like that. But in this case, we're taking it to the Jetson, and the Jetson is saying, okay, I want it to look like a specific kind of codec, or film stock, I should say. And then it's like, okay, well, now I have to create a ProRes file of the emulated film stock live as it's going through. So instead of just saying, so the pipeline ends up looking a little more complicated. The pipeline is image sensor to your smart LUT, your smart LUT to the preview screen output, the preview screen output to a proxy file, and then that proxy file also has the raw file being written to the card at the same time. So the Jetson is doing a lot of heavy lifting. So we're probably going to end up needing some kind of FPGA that does all of the image processing or something first, takes the image processing, splits it off into two sections, and gives it to the the Nano on, or the Jetson Orion, I think we're using now. But yeah, it's all very fun and complicated, and I really enjoy the programming aspect of everything. And I like this shape. This is fun. Really doing up enough distance and angle. Yeah, let's go all the way. Woo! Woo! Fill it for me. Okay. I mean, that's not right at all, but I like that. Yeah, something like that. Okay, cool. And this will all be done on 5-axis too, so you know, at least this, the person machining this will throw it in and have AI code, or make the G code and spit it out and not have to worry too much about it. So I feel bad for machinists. I feel bad for old machinists who don't do stuff like how we do it now. Can I just follow this path, do you think? Do you think it'll let me? Probably not. No. We. My sensitivity is set very high. That is nice. Yes. That's better. No. There we go. Yeah. What is this? What is this shit here? Hold on. Let's see if Fusion will let me get rid of it, because that is unnecessary. Oh, what is this? Where did it click over here? Oh, this whole thing is a thing. Huh. Delete. Nope. All right, fair. Just do one at a time. I didn't like that. No. Huh. All right. Mmm. All right. So this is just some weird, funky geometry here that Fusion can't figure out how to make this line go across. All right. Fuck it. Whatever. Let's see. Can I take out this at least? No. Still no. Okay. How about no? Wow, Fusion, terrible. All right, so let's take a look here at this. This is not gonna work because the mag is there. No, I got a text message. Because people want to go out, says Alex. Let's see. Okay. Let's do a little bit of that. That. Do one across it. Yeah, this will be lower, so I should follow this line here. Yeah. Okay. Something like this. Yeah, something like this. Although this is pretty sketch too, I will say. Like normally I shouldn't be doing this. This is like super. This is not very clean. Someone, I want it to be a lot cleaner geometry wise than this, but well, I mean that's not the worst. It could be way worse. It's not like that. Yeah, okay. Oh, 0.8, huh? That is not very thick. 0.8. Here's something. I don't even know if I finished what I was talking about. Huh. What does that do? Huh. That's a fun little shape. All right. Let's do this. Yeah. 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 No. Sweet. Yep. Yep. Like it. Nope. Didn't like that. That's not gonna work either. Should have done parallel. Oh, it is parallel. Ooh. Well, that's horrendous. I mean, that sort of works. Doesn't like that. Interesting. Okay. No. Oh, I can't imagine it would figure this out. No. Okay. And then this won't let me drag it, will it? No. Just some weird shit. Let me just delete this. See what happens. Just delete the whole fucking thing. Sure. Let's do this then. I suppose I could make this out of plastic too, but everyone is very much so expecting it to be metal. I didn't need to do that. I didn't like that at all. Okay. Oh, this is such a non-issue. Oh, I don't like dealing with this. Just come on, Fusion. Come on. Really? Okay. You don't like deleting that. Really? Things would be a slam dunk. Let's see. Something like that. Really? God, I'm always perplexed by what Fusion doesn't like to delete. Thank you. Nothing. Oh, I can't figure it out. My little Fusion brain doesn't know what you want to do. You know what I want you to do. It's right there. It's literally right there. Alright, whatever. It's not gonna do with it. Okay, let's just do this. Sure. Not what I meant. But it closed the gap, so I'll take it. Perfect. Exactly. Yeah, just do whatever the fuck this is. Sure. Actually, this might be good. Yeah, because then we can create like a and then ooh, I should really hmm. Head spinning. So much interesting geometry. Seriously? Just delete it. Thank you. Good God. And then this is weirdly flappy. Look at that. Yeah. So, okay. We go back to the magazine here. Let's see what's touching. Right. Okay. Let's do a little bit of this. And no. Mag deleted. Yeah, this is what we want. Get rid of that shit. Face. Perfect. That is perfect. Yeah. Cool. Everybody apologize to your machinists for what you're about to do to them. Nice big swoops here for the 5th axis to come in and save us. Yep. Yep. Good. Good, good. Very nice boats. Nice boats. Good boats. Cool. Yeah, and then that will intersect nicely. Our screen still has room here, and what's going to end up happening is I'm guessing this piece will just continue up through here to fit the screen in. Obviously, I haven't designed that yet, and I will when I have the screen PCB. So we kind of just do what we can right now until all is well. And that will be brought up maybe at some point, but this is looking pretty fly. So something else to keep in mind too, when this piece comes in over here, there's going to be a metal piece that holds this motor on from the left side. And then so it's going to look like this, right? You're going to have your camera body here. And this piece is going to probably come out a little bit here, maybe duck down a little, and then go all the way back to here, where it's going to go here, and then combine like that. And then there's like a little stick out area here for this guy, because this floats out there. So then there's going to be two power limos right here and here, both are 12 volts. You will have a SDI poking out right here for the front monitor. And then there will be three SDIs here and an HDMI right here, as well as a USB-C on the top here, which you won't see. But basically all this is hidden inside of a little cavity that's like this. This is the shape of the board. And then there's a physical line dividing all the electronics from basically all the movement stuff, so no light can get in. And you'll have your ribbon cable port right here, which will be a rubber seal ribbon port. And then, due to a lot of feedback we got at CineGear, we're going to actually have a battery mount back here now, so it should be more flush with everything. And then, of course, I'll design a swanky top handle. And that's your camera. That's your camera right there. Should be pretty nice. And then there's these little magnets that sit on here. I forgot to mention that when I was going through the magazine, but this is some very strong neodymium magnets, and then on this receiving side there will also be neodymium magnets, and that will control your magazine speeds and stuff. And yeah, if anybody has any thoughts or comments on things that I forgot, I mean, there's obviously a lot left, but it's not a big deal. It'll get done, I promise. We're close. That's pretty huge. We're always close. But if there's any questions or comments or concerns, please let me know. I'm gonna go to bed.